Hi everyone, welcome back. We continue on this module and today we are gonna start image processing part, and here we are gonna start with Canny Edge Detector, which is one of the famous filter we can say. And in this part also we are gonna see the differences with the CUDA and without CUDA. We are gonna run the code with both and we are gonna see the differences, time differences, and we are gonna talk about the other things. Okay. The usage is very easy. You are just needed to call this one. Let me copy by the way this one, and here you need to define your low and high threshold and aperture size accordingly. Also the gradient is gonna be false or not. By the way, if you are not familiar with the Canny Edge Detector, you can watch my more older video about the Canny Edge Detector, because in this video we are gonna focus on how to run Canny Edge Detector with CUDA with GPU. So we are gonna focus on that one. We are not gonna focus how Canny is working. Okay, we can switch to the code part. This is the code from the previous video. We can remove these parts. This GPU upload and download part can stay, and the duration also can stay, because we are gonna see how the time is how much time is spent for the process. Okay, after this everything is done. Okay, we are gonna use Lena image again. By the way, since we are dealing with now this image processing part, we need to include the library. Just include OPENCV 2 and CUDA image processing HPP. Okay, now we can reach to the codes. I already copied this from the function documentation, and in here I just need to put CV pointer and also CUDA. I need to put, I think so, CUDA. Okay, Canny Edge Detector, and seems everything fine in here. Okay, I need to define, this is CUDA Canny, maybe we can call, is equal to this one. I need to define the parameters. There are 3 parameters, which is the most famous parameters is 150 and 150, aperture size 3, and the last one can be true also. These are the mostly default parameters. I don't know if there's a default in here or not. Let me check. Okay, there's no default ones, but for aperture size 3 and gradient is defaultly false at least. These are you know, the suggested ones is low thresh is 3 times of the low thresh is gonna be high thresh. Also generally 50 is better in most of the cases, we can say at least. And we defined the object, and now we can call the CUDA Canny dot. All we need to do is just calling the detect function, and there are 2 overloaded one. We can use, maybe the first one is gonna be better for our example, and we are gonna give the input image. In here, of course, you need to be careful. In the previous video I already explained, you need to give the input as GPU mat. In here also, if you go to function, okay, this input array, they are not saying GPU mat in here, but it should be GPU mat type. Okay, input and the output we need to give, and everything is gonna be calculated accordingly because we already give the parameters. Okay, and we are gonna get the output. After it's done, we are gonna calculate the time. Why I'm not calculating all the download and input upload parts? Also there is these parts I'm not calculating, because in the previous video also I explained these are taking long time. These are not good to compare. Now we are only focusing the operation, how much the operation takes time. So we are gonna compare without CUDA also. After this, the normal Canny Edge Detector we are gonna try. So I'm not including this part. If you include these parts, again I'm saying it's gonna take long time than without CUDA operation. So this is important, I already explained. Okay, then output we are gonna take, and after that we are gonna download it and we are gonna see the output. Let me check one more. Okay, we can run the code. Okay, so already done. This is my Canny output. It's already detected the edges, and this is the output after filter, and it takes approximately 1000 microseconds. We can say 1 millisecond, and let me run a couple of times. Okay, each time is taking approximately 1.1 millisecond. Then now we can call the normal Canny Edge Detector. For that one I want to remove here, not to make confusing these parts, and let me remove at all. Okay, nothing remaining with CUDA things. Okay, Now we can call the normal Canny function. Just all I need to give the image, not input, of course, there is no input already. And after that I need to give the out to see the output. Threshold 1 is gonna be 50 and threshold 2 is gonna be 150, aperture size 3, and the other one is gonna be 2. Okay, and let me calculate the time for this one. Okay, 3 millisecond, 2 millisecond, 2.6, we can say approximately 2.5 millisecond, which is 2.5 times slower than the CUDA part. So you see, this is the expected one, of course, but again I'm saying to you, if you including these parts, this one is gonna be the speeders, is gonna be the faster, as I said, as I explained in the previous video. So again I'm saying, I'm reminding, okay, you can use Canny Edge Detector, but if it's worth. What I mean, if the process or the inputs are really huge data, so it's gonna be better to use CUDA, of course, because otherwise this is gonna be the slower, because the trade-off, there's a trade-off in uploading and the downloading takes long time also, so it should be worth to upload the images into the GPU side. This is the warning again I'm telling, so this is the important case. So also I want to be sure these data we see before with the GPU, these are the same data or not, because you know, right, we are giving the same parameters, so I'm expecting it should be the same data. Let me comment out again, and I want to compare the Canny output, so they are same or not. For that one I want to create one more output normal Canny maybe, or out CPU we can say, sorry. Okay, this is gonna be my CPU output. All I need is giving here, and okay, I want to see here output CPU, and everything is done. How can I compare these things? There are a couple of ways, but I want to see the visualization, how is the difference. So I want to call CV absolute difference. For that I need to create a different math for diffs, and all I need just giving the output normal, which is GPU output, and output CPU, and the last one is gonna be the diff. So this is gonna give me the differences in the white pixels, so I want to see the difference also at the end. Diff. Okay, let's see the result. You see, there is, when you directly look at, there is no differences you can see, at least, but in the reality there are differences, mostly in the edge sites. These are most probably there are some different algorithm for the edges. So in the GPU side there is a small difference we can see. These are not really important, but at least you should know the algorithm behind this one and this one even looks like same. There are small differences. Maybe for now or for most of the cases this is not gonna be important, but you should just keep in your mind. Okay, here you see there is a 1 pixel difference. Sometimes these are not important, but if you deal with very detailed data, you should also consider this one. You see there is still some differences, even could be ignored. Yeah, but we can ignore in most of the cases, again I said. Yeah, for this video I just wanted to show how Canny Edge Detector is working for the CUDA module, and how we can run it, and also we see the time differences between CPU and between GPU side. And yeah, for this video I just wanted to explain this one. Thank you for watching. See you in the next videos.